So what we have done till the previous class was Bernoulli's theorem. Now let us see what is loss of head. So if you look at Bernoulli's theorem, it says that V1 square by 2G plus P1 by W plus Y1. This is equal to V2 square by 2G plus P2 by W plus Y2. So this is your Bernoulli's theorem. So with the help of this, let me explain you what is loss of head. So let us say that any fluid is entering, water is entering through this location, and this is a pipeline. You have three exit points at various locations. So let us say the pressure here is 2 bar. So if the pressure here is 2 bar, the atmospheric pressure here is 1 bar. So what will happen is when fluid passes through this location, it will rise to a certain location. It will rise to a certain height. Okay? This height, this pressure, this height corresponds to this height H1. It corresponds to a certain pressure P1 given by rho G H1. Now, this height will be corresponding to approximately 1 bar. So you have 2 bar entering here. 1 bar is the pressure head being generated here, and 1 bar is the atmospheric pressure, and it balances itself. When this fluid flows further ahead, due to friction, what will happen? Let us say that due to friction in this pipeline, the pressure here becomes 1.7 bar while entering this. So here the height will be corresponding to 0.7 bar. Here the height will be corresponding to 0.7 bar. So this height, let it be H2. So the loss of head will be H1 minus H2. Because if it was a completely friction-free surface, then what would have happened? All these heights would have been the same. सबकी हाइट बराबर होती, सारे H1 ही होते. फ्रिक्शन की वजह से लॉस होता है. दूसरा क्या है? Let us say that this is having 10 mm diameter. If the diameter here is less, then again the pressure will increase or decrease depending upon continuity equation, which says that A1 V1 is equal to A2 V2, and this is equal to discharge, where Q is called as discharge. Okay, and here according to this, if the diameter is less, area will be less, velocity will increase. If velocity will increase, then pressure will decrease. So again you have a drop. In that case, what happens? This is loss of pressure head due to decrease in dimensions or decrease in system properties or dimensional properties. So again, in that case also, you will be having a loss of pressure head, or there is sometimes an increase of pressure head also. Where there will be an increase of pressure head? If suppose this diameter is more. If the diameter is more, velocity will be less. Velocity will be less. That means pressure will be more. So here, if the pressure is more, you will get a greater height. H2 will be more. So if H2 will be more, what will happen? You will have a greater H1 minus H2 will be negative. That means there is an increase of pressure head. So loss of head is actually the loss taking place either due to friction or due to dimensional properties. Okay? Or maybe if the fluid is flowing in this direction. If the fluid is flowing like this, let us say this is a pipeline and this is your datum level. So if the fluid is flowing like this, again, this is Y2, the final height, and this is 0. So due to change in height also, you can have a loss of pressure head. Okay? So your job will be to measure the pressure heads at various locations due to various system properties. This can be due to loss of increase or decrease of height, increase or decrease of friction, or normal under operating. If the operating conditions are vary, then also you can have a increase or decrease of pressure head, and that is called as loss of pressure head. Now let us take a small numerical based upon Bernoulli's theorem. The numerical says that a pipe 300 meters long has a slope of 1 meter in 100 and tapers from 1 meter diameter at high end to 0.5 meters at low end. Quantity of water flowing is 5400 liters per minute. If the pressure at the high end is 70 kilopascal, find the pressure at the low end. इस प्रॉब्लम में गिवन क्या है? इनलेट डायमीटर है 0.5 मीटर्स, आउटलेट डायमीटर है 1 मीटर, 300 मीटर लंबा पाइप है. सो द लेंथ ऑफ द पाइप इज 300 मीटर एंड द स्लोप इज ऑफ 1 मीटर इन 100. इसका मतलब है देयर विल बी एन इंक्रीज इन हाइट विथ एवरी 100 मीटर्स डिस्टेंस ट्रेवल. हर 100 मीटर ट्रेवल करोगे तो 1 मीटर इसकी हाइट बड़ी हो जाएगी. जितना इसमें पानी बह रहा है, that is 5400 liters per minute. If the pressure at the high end is 70 kilopascal, find the pressure at the low end. So this is the diagrammatic representation of the pipe. Okay. Now what is the inlet area? It is pi by 4 d square. So this is 0.196 meter square. This is the outlet area. This is pi by 4 into 1 square. We have taken all units in meters. So this is 0.785 meters square. Now the discharge is given as 5400 liters per minute. You need to convert this into second. So this is 90 liters per second. How did we get this? 5400 divided by 60. ठीक है, तो ये हमें 90 लीटर पर सेकंड मिल गया. 90 लीटर पर सेकंड ऑफ वाटर इज इक्वल टू 0.09 मीटर क्यूब पर सेकंड. कैसे आया ये 0.09 90 लीटर? बिकॉज डेंसिटी इज mass per unit volume. So volume is given, mass is given 90 liters per second. So volume you can find it out, divided by 1000. So you get 0.09 meter cube per second. Now by continuity equation, Q discharge is equal to A1 V1 is equal to A2 V2. Continuity equation हमने क्या पढ़ा था? Rho AV is equal to constant. हमने पढ़ा था rho AV is equal to constant. Rho is the density of the fluid. We are assuming that the density of the fluid does not change while flowing from one location to another. So if the density remains constant, then AV is equal to constant. If AV is equal to constant, this constant is discharge, the net amount of fluid flowing through the system. So if you put Q is equal to A1 V1 is equal to A2 V2, तो पहले आप Q is equal to A1 V1 लीजिए, तो इससे V1 निकलेगा. Q आपको पता ही है 0.09 और एरिया कितना है 0.196, वो हम निकाल चुके हैं. सो द वेलोसिटी एट इनलेट इज 0.46 meters per second. V2 is the velocity at exit. Then Q is equal to A2 V2 से इक्वेट कर दीजिए 0.09 डिवाइडेड बाई exit area आपको पता ही है. So this gives you 0.115 meters per second. Now apply Bernoulli's theorem. The Bernoulli's theorem says that V1 square by 2G plus P1 by W plus Y1 is equal to V2 square by 2G plus P2 by W plus Y2. Bernoulli's theorem is energy equation. You are applying first law of thermodynamics, that energy can neither be created nor destroyed. It can only be converted from one form of another, from one form to another. So here you have the total energy at exit. This is equal to total energy of exit at exit. So total energy of entry is equal to total energy of exit. You are equating what you are equating. You are equating for per unit mass. You are equating kinetic energy, potential energy, and pressure energy with kinetic energy, potential energy, pressure energy, and potential energy at exit. Now, if you look at the diagram, you can say that y1 is equal to 0 because there is, if this is your centroidal axis, then this is 0. That means the entry height is 0. Now you need to find out the exit height. Exit height, it is said that has a slope of 1 meter in 100 meters. So if it has a slope of 1 meter in 100 meter, so over a length of 3 meters, what will 300 meters? What will be the change in height? So the change in height will be 1 by 100 multiplied by 300. So this gives you 3 meters of change in height. Now apply Bernoulli's theorem. It says that 0.46 whole square. This is entry velocity divided by 2 into 9.81 plus this is the entry pressure, which is denoted by P1 divided by 9810 plus 9810 is the specific weight of water plus 0 because the entry height is 0. This is equal to 0.115. This is exit velocity 2 into 9.81. The exit pressure, you can see that the pressure at the high end is 70 kilopascal. So this is 70 into 10 to the power 3 divided by 9810 plus 3 is the change final height. If you put down these values, you can see that this is a single equation, single variable problem. You will find P is equal to 99,330 Newton per meter square, which is equal to 99.33 kilopascal. So this is your complete solution of the problem. Now let us see the second numerical. Second numerical is a 60 centimeter diameter pipeline carries oil whose specific gravity is 0.85 at 82,500 meter cube per day. The friction head loss is 8.5 meters per 1000 meter of pipe run. It is planned to place pumping stations every 20 kilometer along the pipe. Find the pressure drop between pumping stations. अब है क्या कि एक 60 सेंटीमीटर का डायमीटर का पाइपलाइन है जिसमें ऑयल जाएगा 0.85 स्पेसिफिक ग्रेविटी. ऑयल का टोटल डिस्चार्ज जो एक्सपेक्टेड है या फिर जो चाहा गया है वो है 82,500 मीटर क्यूब पर डे ऑयल ट्रांसफर होगा एक जगह से दूसरी जगह से. द फ्रिक्शन हेड लॉस इज 8.5 मीटर. फ्रिक्शन हेड लॉस का मतलब है कि जो फ्रिक्शन की वजह से आपका हेड लॉस होगा, डिफरेंस इन प्रेशर क्रिएट होगा, वो है 8.5 मीटर्स. ठीक है, पर 1000 मीटर ऑफ पाइप रन, 1000 मीटर पाइप रन होगा तो 8.5 मीटर्स का आपके कॉरेस्पॉन्डिंग आपका फ्रिक्शन हेड लॉस होगा. अब प्लान क्या किया गया है कि हर 20 किलोमीटर के बाद एक पंपिंग स्टेशन रखेंगे. क्यों? क्योंकि फ्रिक्शन की वजह से जो प्रेशर लॉस होगा वो प्रेशर लॉस को कवर करने के लिए हर 20 किलोमीटर के बाद एक पंपिंग स्टेशन लगाया जाएगा जो कि प्रेशर को दोबारा उतना ही कर दे ताकि आपका ऑयल फ्लो हो सके. ऐसा नहीं होता है कि हम एक जगह से दूसरी जगह अगर जैसे हम पानी भी फ्लो कराते हैं, अगर गंगा वाटर पाइपलाइन भी अगर देखें तो आपने गंगा वाटर जहां से एक्सट्रैक्ट किया उसके बाद हर थोड़ी थोड़ी दूर पे 20 किलोमीटर 50 किलोमीटर 100 किलोमीटर के बाद एक पंपिंग स्टेशन होगा ताकि जो आपका प्रेशर डिफरेंस हुआ है ड्यू टू फ्लो, जो फ्रिक्शनल लॉस हुआ है उस लॉस को कवर अप करने के लिए एक पंपिंग स्टेशन लगाया जाता है ताकि द प्रेशर इज मेंटेन. सो इसमें पंपिंग स्टेशन 20 किलोमीटर के बाद प्लान्ड है. नाउ लेट अस अप्लाई Bernoulli's theorem. So Bernoulli's theorem says that P1 by W plus V1 square by 2G plus Y1 is equal to P2 by W plus V2 square by 2G plus Y2 plus friction loss. अब फ्रिक्शन लॉस आउटपुट में जोड़ा गया है. ठीक है, आउटपुट में क्यों जोड़ा गया है? क्योंकि इनपुट में तो यहाँ पे पंपिंग स्टेशन लगा ही था, यहाँ पे जो लॉस है वो एग्जिट पे आपका कवर अप होगा. Now since the pipeline is laid horizontal, obviously there is no taper in the pipeline, So the pipeline is laid horizontal, तो इसका मतलब y1 is equal to y2. There is no change in height. अब पाइपलाइन में आपको ये भी नहीं बताया गया है कि there is a change in the diameter. So if there is no change in the diameters, the velocity v1 will be equal to v2, because a1 v1 is equal to a2 v2. If a1 is equal to a2, then v1 will also be equal to v2. So this you can understand as a1 is equal to a2, so v1 is equal to v2 by continuity equation. Okay. Now P1 minus P2 by W, if you put it into the Bernoulli's theorem, V1 वाला term cancel out हो जाएगा, Y1 और Y2 वाला term cancel हो जाएगा. So P1 minus P2 by W is equal to HF. This is frictional loss. So P1 minus P2 by W is equal to HF. Now what is HF? It is 8.5 by 1000. There is a loss of 8.5 in 1000 meters. So what is the loss in 20 kilometers? So this is 20 into again 1000. So you have 170 meters. This is the loss of head. Loss of head question में given है कि 8.5 meters का होता है 1000 मीटर पे. तो 20 किलोमीटर पे कितना होगा? 20 into 1000. So this is 170 meters. So P1 minus P2 is equal to P1 minus P2 by W is equal to 170. So P1 minus P2 is equal to 170. Oil of specific gravity that is given 0.85 multiplied by 9810. This is equal to 1417, 1417.55 kilonewton per meter square. So this is the total loss of head or change in pressure that will take place between two pumping stations. This is the total change in pressure that will take place between two pumping stations. Okay. Now here a pipeline carrying oil of specific gravity 0.87 changes in diameter from 200 mm at position A to 500 mm at B, which is 4 meters higher. If the pressures at A and B are 1 bar and 0.6 bar and the discharge is 0.2 meter cube per second, determine the loss of head. The loss of head means loss of energy which is taking place due to this flow. So I have drawn this diagram. The entry diameter is 200 mm. The exit diameter is 500 mm. Here you have 1 bar. This is point A and this is point B, and the exit is 0.6 bar. Now, what is the velocity at A? This is 0.2. Q divided by A is velocity because Q is equal to AV. So Q is 0.2 meter cube per second and area is pi by 4. 200 mm is 0.2 meters. So 0.2 whole square. So this gives you velocity at entry as 6.37 meters per second. Now velocity at exit, again Q divided by A2. This is 0.2 divided by pi by 4, 0.5 whole square. So this is 1.02 meters per second. Now the energy head available at A. The energy head available at A is denoted by EA. This is VA square by 2G plus PA pressure at A divided by W plus YA. VA we know it is 6.37 whole square, 2 into 9.81. Pressure at entry is 1 bar. This is given. So this is 1 into 10 to the power 5. You need to convert everything into Newton per meter square. Divided by 0.87. This is the specific gravity multiplied by 9810. Plus 0. Because the entry height is 0. So this gives you 13.785 meters. Now what is the energy head at B? The energy head at B is VB square by 2G plus PB by W plus YB. So this is 1.02 whole square, 2 into 9.81 plus exit velocity, exit pressure is 0.6 bar. So 0.6 into 10 to the power 5 divided by 0.87 into 9810 plus 4. The change in height is 4 meters. So this is 11.083 meters. The loss of head is the change in energies that has taken place at entry and exit. So the energy head available at entry is 13.8785. The energy head available at exit is 11.083 meters. So if you subtract them, the difference is 2.702 meters of oil. This is the total loss of head that has taken place due to friction or due to change in the diameters for this problem.